Has the solution been found so that electric vehicle batteries do not catch fire? Let's see. Lithium-ion batteries have evolved significantly in recent years, offering electric vehicles increased range, shorter charging times, and increased safety when charging. However, there is always the possibility of fire for many reasons, but according to several studies, electric vehicles are even now less prone to fire, since in proportion of vehicles they catch fire less often than internal combustion vehicles. Of course, the big problem for lithium-ion batteries is that once they catch fire they are quite difficult to fight since they need a lot of water for a successful extinguishing. On the other hand, for a battery to catch fire, there can be several reasons. Usually, the rate at which the batteries are charged is carefully chosen to avoid problems, and is one reason why these batteries have a wait to charge, worrying many prospective buyers. In some case of a malfunction in fast charging, lithium plates begin to form near and around the anode, resulting in a short circuit and excessive heat where it can ignite the flammable electrolyte, ultimately resulting in the spread of fire. Also, the increasing number of cells in new batteries require stricter quality controls, since some manufacturing defects can lead to small metal fragments and small holes, giving a high probability of ignition after a short circuit inside the battery. Accidents on the roads with the participation of an electric vehicle still give a high probability of ignition, since the battery in a violent vibration can lead to its destruction and the immediate cause of fire. But despite some battery issues, factories carry out detailed quality checks to ensure that the product has high reliability rates, but as in any area of technology, this possibility is unlikely to be eliminated. That's why scientists are constantly working on new ways to create a battery that has the least possible risk in a difficult situation. And that's probably changing, since researchers at Clemson University in South Carolina thought to simplify solving the problem, since inventing an electrolyte that doesn't ignite would be a major turning point for safer batteries. A commercial fire extinguisher was, let's say, the source of inspiration, where instead of a common electrolyte where in most cases it consists of a lithium salt and organic solvent, the scientific team developed one where its materials are based on a commercial fire extinguisher, as we mentioned before. This innovative electrolyte can operate in extreme temperatures from about -100 to 175 degrees Fahrenheit or -75 to 80 degrees Celsius. Also, these batteries produced in the laboratory received tough durability tests, and the result was extremely encouraging, since with this flame retardant the fires were effectively extinguished. The advantages of the revolutionary electrolyte do not stop here, since it is compatible with chemicals other than lithium ions such as potassium ions, aluminum ions, sodium ions, and zinc ions. This means that the adaptation in commercial form may not be costly, since its compatibility is a particularly important element. On the other hand, electrolytes that do not ignite are nothing new, since similar technologies use fluorine and phosphorus, but there is a serious disadvantage here. These electrolytes are highly expensive and may not be environmentally friendly, with harmful effects on long-term use. But what makes the difference to the Clemson University team is that they investigated the adaptation of cheap commercial refrigerants such as those widely used in fire extinguishers. The main goal was to adapt them as battery electrolytes to achieve the desired effect. Thus, the basic material used in scientific research for this innovative design is the Novec 7300, where it is distinguished for safety. It is also environmentally friendly since it has low toxicity, does not contribute to global warming, and is an affordable commercial liquid. The combination of the liquid with different chemicals created a durable and functional electrolyte. But what happens from now on? Will the industry adopt this revolutionary electrolyte? It will all depend on whether industries test the new electrolyte and whether the results from the tests will point the way to mass production. What is important, however, is that the manufacture of non-flammable batteries does not affect existing lithium-ion installations, while other types of batteries are being investigated for the application of the new electrolyte, such as sodium-ion, aluminum and zinc batteries. One thing is certain, however, this breakthrough will not only improve the safety of electric cars but also appears to be a completely environmentally friendly solution for the industry. But can battery technology evolve from now on? And how much? Of course, it is not something completely new, but due to the revolution of electric vehicles, batteries will rise to a new level of performance that no one had imagined in previous years, and not only that, because it will benefit other forms of mobility since in recent years there has been no significant progress. We'd like you to give us your perspective in the comments below on how battery technology will evolve.